of a complex number. Today we are going to discuss some problems on complex numbers. Z equals to lambda plus 4 iota upon 1 plus lambda I, where lambda belongs to real numbers. Given that Z is a real number, that means what? Imaginary number is 0. Find the possible values of lambda. Let's see how to approach this problem. Given Z equals to lambda plus 4 iota upon 1 plus lambda iota. I want to rationalize the denominator by using the conjugate of 1 plus lambda iota. So we have to multiply 1 minus lambda iota upon 1 minus lambda iota. So that equals to lambda into 1 lambda plus into minus lambda times of lambda iota is lambda square iota. Now positive into positive, 4 iota into 1, 4 iota, positive into negative. Now 4 into lambda, 4 lambda, iota into iota, iota square is -1, so negative of negative, positive, so 4 lambda upon 1 plus lambda iota times 1 minus lambda iota. These two are in the form of a plus b into a minus b. So we can write it as 1 square minus lambda iota whole square. So finally, lambda plus 4 lambda, that means 5 times of lambda, plus I am taking here iota common, iota times of 4 minus lambda square upon 1 square means 1, iota square is -1, negative of negative, positive lambda square. Can I write it as 5 lambda upon 1 plus lambda square plus iota times of 4 minus lambda square upon 1 plus lambda square. Observe here, it is in the form of general form of a complex number. That means what? A plus iota b. So here 5 lambda plus 1 plus lambda square is the real part of the complex number. 4 minus lambda square upon 1 plus lambda square is the imaginary part of complex number. But in the question they given very clearly Z is a real number. Therefore Z is a real number means if Z is a real number, that implies imaginary part of Z equals to 0. What is imaginary part here? 4 minus lambda square upon 1 plus lambda square equals to 0. Observe here. Left side quantity is a fraction, it is equals to 0. When a fraction equals to 0, when its numerator equals to 0. Why? If you consider denominator equals to 0, it is undefined. So, you have to understand here, 4 minus lambda square equals to 0. So, lambda square equals to 4. So, lambda equals to square root 4. Therefore, lambda equals to plus or minus 2. So, these are our required values of lambda, positive 2 as well as negative 2. I hope it's clear. Now, let's find the values of x and y in the equation. X times of 1 plus iota whole square plus y times of 2 minus iota whole square equals to 3 plus 10 iota, where x belongs to real numbers and y is also belongs to real numbers. Let's observe this one. Given x times of 1 plus iota whole square plus y times of 2 minus iota whole square equals to 3 plus 10 iota. Observe very carefully here. X times of 1 plus iota square, it is in the form of a plus b whole square. So a square 1 plus b square, that means lambda square. That means here, sorry, iota square. It's nothing but -1 plus 2ab, that means 2 iota. I hope it's clear. Plus y times of 2 minus iota. It is in the form of a minus b whole square. A square 4 plus b square means iota square, but iota square is negative 1, so negative 1 minus 2ab minus 2 2s are 4 iota equals to right side what is running 3 plus 10 iota. That implies x times of positive 1 and negative 1 get cancelled, so you got 2 iota plus y times of 4 minus 1, 3 minus 4 iota equals to 3 plus 10 iota. Now I am rearranging the terms. 2 iota into x, 2x iota. Now plus into minus, minus 4 iota into y, 4y iota plus 3y equals to 3 plus 10 iota. Observe very carefully here. I am writing the real part first, 3y plus, if I will take common iota here, iota times of 2x minus 4y equals to 3 plus 10 iota. Now compare the values of the equation. Observe, here the real part will be what? 3y. Here the real part is 3. That means comparing the coefficients, you will get 3y equals to 3. That implies, can I say that y equals to 3 upon 3? That equals to 1. Now, in the same way, 2x minus 4y equals to 10. What is the y value? 1. Substitute 2x minus 4 times of 1 equals to 10. So 2x equals to 10. Negative 4 transposing that side positive. So 2x equals to 14. So x equals to 14 upon 2. That equals to 7. Therefore, what are the values? X value is 7 and y value equals to 1. I hope it's clear. Now, we'll discuss the next problem. So, let's see the next problem. Z equals to x plus iota y. Omega equals to 1 minus iota z by z minus iota. Show that if mod omega equals to 1, then z is purely real. That means we have to prove z is purely real if mod omega equals to 1. Now we'll start. Given mod omega equals to 1. Right? Now observe here. What is omega? 1 minus iota z by z minus iota equals to 1. Can I write it as modulus of 1 minus iota z upon modulus of z minus iota equals to 1? Why? We know that modulus of z1 upon z2, we already discussed it, equals to modulus of z1 by modulus of z2. Properties of modulus, if you don't know, please watch my previous videos, then you will get a clear clarification on the properties of modulus of a complex number. Now, by doing the cross multiplication, 1 minus iota z equals to z minus iota. Now, that implies 1 minus iota times what is z? X plus iota y. Just I replace the value. Equal to what is z? X plus iota y minus iota. Now observe here, that implies modulus of 1 minus iota x plus iota into iota square. Iota square is negative 1, negative 1 into y, negative y, but already negative is there. Negative of negative, positive. So can I write it as 1 plus y minus iota x? I hope it's clear. That equals to, here x plus, if you take common iota, y minus 1. We know that if z equals to a plus iota b, once I am recalling, that implies mod z equals to what? Square root of a square plus b square. By using this, observe here, what we can write here? Square root of 1 plus y whole square. In place of a, 1 plus y is there. Plus b square, in place of b, what? X square equals to. What about the right side one? Square root of the modulus. In place of a, x is there. So x square plus in place of b, y minus 1 whole square. Now, both sides, squaring on both sides, or we can cancel directly square root and square root get cancelled on both sides. So we got 1 plus y whole square equals to x square plus y minus 1 whole square minus x square y. Here the positive x square, just I transferred from negative to, that means it becomes negative. So positive x square and negative x square get cancelled. So what I will get now? 1 plus 2y plus y square, while expanding 1 plus y whole square equals to y square plus 1 minus 2y, while expanding y minus 1 whole square. Observe here, can I write it as 2y, negative 2y, I am transposing from right to left, it becomes positive 2y equals here y square plus 1, just transpose positive 1 become negative, positive y square become negative y square. So left side what you got? 4y equals to right side positive y square get cancelled, positive 1 negative 1 get cancelled, we got 0. 4y equals to 0, but here 4 is a non-zero negative, positive y square become negative y square. So left side what you got? 4y equals to right side positive y square get cancelled, positive 1 negative 1 get cancelled, we got 0. 4y equals to 0, but here 4 is a non-zero quantity, so y should be 0. So you got y equals to 0, but y is what? Imaginary part of complex number. Imaginary part of complex number is 0. That means imaginary part of complex number is 0 is nothing but, can I say, z is purely real? Purely real. I hope it's clear. So these are some of the problems on complex number. In my next video, we will